This is a shout out to Lexi Garcia. Congratulations, Lexi. You are now famous. Here we go. So we have some video notes here that you can read, okay? What I'd like to get to is some of the problems that we can look at together. So, starting off with number 1, remember that we break this down into the square root of -1 for the negative there in the front times the square root of 16. Okay? So, we're going to have, I like to save this one for last because I can take the square root of 16, which is 4, and then the square root of -1, which gives us I. Number 2. Okay, we're going to get into doing some simplifying of radicals here. So here we have the square root of -1. Okay, and then I'm going to go ahead and look at 28. And I'm going to look at its factors. So when I factor 28, I see 4 times 7. So I'm going to go ahead and break this up to the square root of 4 times the square root of 7, breaking it up into its factors. One of the factors being -1 for the negative out in front. Now when I write this one, I'm going to start off with the perfect square. So the square root of 4 is 2. I'm going to do that one first. Then I'm going to do my I second. And then I'm going to put the radical 7 on the end. And this is simplifying radicals. This is how you simplify radicals. Okay, number 3. We have the square root of -1. That's for the negative on the 5 times the square root of 5. Multiplying. So this time, since we don't have a perfect square here, that's going to go on the end. We're going to put the I first, and then the square root of 5. Okay, number 4. Now, since we're multiplying, I'm going to go ahead and multiply the radicals together, and we're going to get the square root of 20, because -10 times -2 is 20. Then I'm going to go ahead and simplify this, because I know that 20 has factors of 4 and 5. So we're going to have the square root of 4 times the square root of 5. And we always do the perfect square one first, and then we put the oddball on the end. Don't change it to a decimal, leave it as a radical. All right, dividing. So -50 divided by -10 is 5. And that's our answer. Okay, let's look at number 6. I'm going to go ahead and start off by dividing here. We got 3, 21 divided by 7, -6 divided by 2, and we're going to have 3 times the square root of -1 times the square root of 3, and we get 3i radical 3. So squaring the 3, we get 9. Now remember, when you square a square root, the square root goes away. They're inverses. So we're going to have 3 squared, which is 9, times -5. Again, the square cancels the square root. So I squared the 3, and then I squared the square root. So we end up with -45. Again, squaring the 6. Let me write it out this time. Make sure you see what's happening here. And then we're squaring the square root of -8. I'm writing it out this time so there's no confusion. We get 36 And the square cancels out the square root. So we're going to have 36 times negative 8. Oh boy. And we get a positive times a negative. 6 times 8 is 48. And 24, 28. All right, number 9. So it's the cube root. So we're looking for 3 numbers that are the same that multiply to give us negative 27. And that is going to be square root of negative 3 times the square root of negative 3 times the square root of negative 3. If you multiply these numbers together, you get negative 27. So now what do we have here? We have the square root of negative 3 times the square root of 9. I went ahead and I combined these two together to get this. Now, this is going to break up to the square root of negative 1, the square root of 3, and the square root of 9. So we always do the perfect square first, then the I, and then the oddball. Oddball on the end. Okay, turn it over, because you know, Chanel wants me to hurry up. Always being rushed on these videos. I'm already past where I need to be. Subtracting. 64 minus 100. Negative, what? 36. Now, hopefully you can get to the point where you can look at that and you can say that that is 6i. If you don't know how I came up with that, come and see me. Okay, now let me look at what we got here. Let's look at just a couple of these problems. We have I to the 30th power. We want to know what that answer is going to be. Well, the rules to these types of problems are right here. Okay, so what to keep in mind is I to the 4th power is 1. Okay, so what you need to do is, we have how many 4s here? So what we do is we do 4 into 30. Okay, 4 goes into 30 7 times. Okay, so that gives us 28. So we can actually take away 28 here. We have a remainder of 2. Okay, so what we're really figuring out here is I squared. And I squared is negative 1. So the answer is negative 1. Okay, again, 4 goes into 210. Let's see, 5, 4 goes into 10 twice. We got a remainder of 2. So what we're really trying to find out here is I to the 2nd power. We're using the remainder. So that's going to be negative 1 again. Okay, 3i to the 7th, I to the 7th. So again, 4 into 7 goes 1 time with a remainder of 3. So what we're looking for here is I to the 3rd power, which is negative I. So we're going to have 3 times negative I, which is going to be negative 3i. Number 4. Are you getting the pattern here, guys? 4 goes into 25. 6 times. Remainder is 1. So what we need to find here is I to the first power. I to the first power is I. So we're going to have negative 25 I. Are you getting the idea yet? I know I'm over, Rochanel, I'm sorry. I got to make sure we understand. Here we have I plus I to the third. I to the third is negative I. So I plus negative I, 0. Now, let's see what you can do. Okay? You're going to have to know your rules of exponents. Okay? I'm very hesitant to let you guys do these on your own. I think I'm going to do this first one with you. 4 into 19, 4 times, remainder 3. So what we have here is I to the third power, which is negative I. So this is negative I. Sorry about that. So this is negative I. Minus, okay, I to the 16th. So 4 goes into 16 4 times. Okay, so we're going to use I to the 4th power, which is 1. Or let's take a look at this just a tad bit closer. So we end up with I to the 0 power. And remember, anything raised to the 0 power is 1. So this is going to be our answer for number 6. I realize that some of you are confused. Okay? But this is imaginary numbers. This is how they work. If you take a look at number 7, we're adding. We cannot add them straight up because they're not like terms. In order for them to be like terms, the variables have to be the same and the exponents have to be the same. So I to the 4th power is 1. So 3 times 1 plus 5 times, and I to the 6th, remember we have to divide to find out really which one we're using. So we're using I squared. And I squared is negative 1. So we have 3 plus negative 5 is negative 2. So I will let you guys attempt these 3 problems for tomorrow. See if you can figure it out. And you know, I'll probably do a little reteach again tomorrow to help you guys out. Have a good night. Sorry, Rochanel, about the long video.